Today we will see what is generative adversarial network, what are their application, how it solves the image problem, what are their different application, and how mathematically a generative adversarial network works. Exactly, we will see this in today's session. So now let's discuss what is generative adversarial network first. So in generative adversarial network, we have two components. First is generator, second is discriminator. Now generator task is to generate and fake images such that which look similar to your real images. Now what is the work of discriminator then? The discriminator work is to discriminate. It means classify the real images and fake images. Now let's discuss what is generator. In generator is exactly task is to generate a fake images which may similar to your real images. Let's take an example of 20 rupees note you have. You fed that 20 rupees note to the generator network. Now generator network, what it will do, it will create a certain samples of images which look similar to your 20 rupees original note. Now let's discuss what is generator training. In generator training, first we have a generator. Generator will generate a sample of images. We send that sample of images to the discriminator network. Discriminator task is to classify whether given image is real or a fake images. So based on that, it will have a generator loss. So if the generator loss is higher, now we have to back propagate that in order to obtain a lower loss. It means the generator will create an efficient images which look 99.99% similar to your original images. Now let's discuss a discriminator. What is discriminator then? So discriminator is a network, a component in a adversarial generative network where it has the task to classify only a real images and the fake images. Now let's discuss a discriminator training. We have discussed a generator training. Now let's say a discriminator training. In discriminator training, we have real images. That real images, we send the samples of the real images to a discriminator. Again, a generator model has generated some of fake images. Based on that, it generates some discriminator loss. Let's suppose the discriminator loss in first forward propagation, it will be 0.83. Now its task is to minimize that loss by doing back propagation. Now let's discuss a GAN. In GAN, here the example is given of 100 rupees coins, where we have a real images as 100 rupee coin and fake images generated by generator network is 100 rupees coin. We fed that to the discriminator network. The discriminator network will classify actual and fake notes. Now let's discuss how GAN mathematically works. So in order to understand that, first you need to understand the notation. First, G is represented by your generator, D is nothing but a discriminator, P is nothing but a distribution of real data you have, and X is nothing but a sample of P data, D of X is nothing but discriminator network. Here it is a complex task where first we calculate the logarithmic of discriminator, then we add with the subtracting with the generator network in order to obtain a entire GAN. So now let's discuss how GAN works steps by step. First, you have to define the problem. Let's suppose you are solving the problem of generating a sketch images from a colorful images. So this is your problem domain. Second, you have to define the GAN. So there are four types of GAN: vanilla, DC GAN. So then third is train a discriminator on real data. Fourth is generate a fake data. Fifth is train discriminator on fake data, and six, you have to train a generator with the output discriminator data. So these is the steps in order to obtain a final output. So what are the types of GAN? So there are four types of GANs. There are a couple of type. So here I have just taken a four types. First is vanilla GAN. So in vanilla GAN, we only have a discriminator and a generator network, which has a multi-layer perceptron, same like a artificial neural network. Then second, we have deep convolutional GAN. When we use the deep convolutional GAN, when you want to obtain a high fidelity images, let's suppose you want to obtain a 2000 by 2000 resolution images. At that time, you may prefer a deep convolutional GAN. Now there is a conditional GAN as well. So the conditional GAN provides some extra label to that generator network. So it may create a real kind of images. Then fourth is super resolution GAN. Whenever you want to create a high photorealistic image, then most of the tasks you may prefer a super resolution GAN. Now let's discuss the application of generative adversarial network. So you can use generative adversarial network for creating a faces of anime as well as a Pokemon character. You have seen and watched multiple animes that can be generated through your adversarial GAN network. Now, second application will be you are generating faces. A human faces you can generate. Let's suppose you have 90s black and white image with you, and you want a color images. You want to see actually how you was looking in 90s period. And if you want to see that, then you can solve that problem using a generative adversarial network. Now, let's discuss a third application, which is in 3D object generation. Whenever you have a 3D prototype and you want to see the simulation of it, then you may prefer using a GAN version, that is conditional GAN and a deep convolutional GAN, that can solve your 3D object generation problem as well. So that's it. If you like today's session, you can subscribe my channel, hit the like button, and if you want such a insightful session, you can follow me. Thank you.